All right, in this section, we're going to be looking at factoring polynomials. First step in factoring, anytime you are asked to do it, is to check for a GCF, or greatest common factor. So that's what we're going to look at in this first couple of examples. If you click on that link there, it should take you to a video of example 1. So I'm going to do example B here. So looking at this expression, we're looking at do we have a greatest common factor. So between 6 and 8, I believe that 2 can go into both of those. They also both have at least one x, and they both also have a t. So 2xt is my greatest common factor there. Once I take that out, then I've got to see what does that leave behind. Well, 6 divided by 2 is going to leave a 3. There were 2 x's, one came out, one stays. The t came out, so it's no longer there. 8 divided by 2 leaves a 4. There was an x, it came out. There was a t, it came out. So we are left with 3x plus 4 on the inside of our parentheses. The next method we're going to look at is factoring by grouping. All right, again, that first one there is available through that link. I'm going to look here at the second one. This first one, or the second one here, the first key thing you need to do is to rearrange the order. So that means that we are going to get those that have y's together and those that have a's together. So if I can do that by simply just switching the order of those two there. So we're going to get xy plus by plus ab plus ax. And then grouping works like this. Group the first two terms together, group the second two terms together. And then from each group, we are looking for what is the greatest common factor. So for the greatest common factor of the first group, I get a y. And it leaves behind an x plus b. And then for the second group, greatest common factor is an a, and that leaves a b plus x. And you will know that you have done it correctly if what you have left on the inside of your parentheses, so here and here, are exactly the same. So in this case, they are the same even though they're written in an opposite order. It is reading the same as x plus b is the same as b plus x. So then we take what was the GCF of each group, so y and then plus a, and that's going to be our first factor, y plus a. And then that one that repeated, we will write it one time behind that first factor. So we have y plus a and b plus x, or x plus b. It doesn't really matter which order that you write it there. Okay, the next factoring method is slide and divide. All right. Here you can read all of those steps. I will say that come test day, you will have to demonstrate that you can use slide and divide. All right, not any alternate methods here. It has to be slide and divide, so you need to make sure that you know how to factor in this manner. You will use this when you're factoring trinomials. So that's anything that has 3 terms, with the highest of those terms being something squared. Right, the first one there is available in that video example. So I'm going to start with the second one to show you how slide and divide works. So like it says, slide, that means you slide and multiply the first term times the last term. So we're going to end up with x squared minus 10x minus 24. And then you're going to ask yourself, are there 2 numbers that I can multiply together that give me that last one, which was negative 24? And if I take the same 2 numbers and I add them together, I get the one that's in the middle, which is negative 10. So we need 2 numbers that we can multiply together that give me negative 24. I take the same 2 and I add them together and I get negative 10. So I believe that is negative 12 and 2. So I'm going to write those as my 2 factors, x minus 12 and x plus 2. Then the divide part comes in, that I will now take each of those factors and I will divide it by that leading coefficient, which in this case was an 8. 12 does not divide by 8 evenly, but I do believe that it can be reduced. So I'm going to reduce it, and it reduces to, let's see, both are divisible by 4, 3/2. Same thing for 2 divided by 8 does not divide evenly, but it does reduce down to 1/4. And in both of these cases, since they still remained as fractions, then the last step is to do bottoms up, which means move that number that's in the denominator of each of those up in front of those x's. So we end up with 2x minus 3 times 4x plus 1. Okay, we'll keep moving right along. The next ones are different special products that you can have, or special factoring. So difference of 2 squares, sum of 2 cubes, difference of 2 cubes, and then a perfect square trinomial. Again, the first one in example 4 is available for you in that video, and then I'm going to do the second one. So in this first one, if this one kind of looks like that perfect square trinomial here, which if you see it says it's a squared plus 2ab plus b squared. It factors into a plus b squared, or if it happened to be minus, which is the case here, then it's a minus b squared. So to figure out a and b, I will take the square root of those the first number and then the last number. So, oops. So if I'm figuring out a, I'm going to take the square root of 9x squared, and that's going to tell me that a is 3x. For the b, I'm going to take the square root of 4y squared, and that's going to be 2y. And then to figure out the term there in the middle, which is going to be 2 times a times b, I'm going to do 2 times 3x times 2y, and we're going to end up with 12xy. So in my factored form, my a is 3x, and then my b is 2y. So this would be 3x minus 2y squared.